Welcome back. Now that we have finalized the code for training the model for one period, we'll proceed to training and generating the predictions of the models over all the periods from the start date to the end date. As mentioned in the previous section, the models have to be refit periodically to avoid model drift. However, training dozens of models sequentially can take a long time. Here, we use the fact that each model can be trained in parallel to be able to train them significantly faster. The parallelization will be done by submitting training and prediction jobs to the node balancer, which distributes them to multiple machines that will run those programs. To do this, you first need to ensure that your node balancer is turned on. In the QuickBench dashboard, just turn on the node balancer and choose which instance type to use. Bench will automatically spawn instances of this type when jobs are distributed. It is important that you select an instance type with RAM greater than what the training and prediction jobs require, so that they will run without running out of memory. It is also important to ensure that the instance type has spot interruption less than 5% to reduce their chance of getting terminated before the job they are running is finished. As for the instance subnet, choose the one with the lowest spot price. Set instance reservation to spot, and finally in the advanced options, set the instance count equal to the number jobs to be submitted or the node limit, whichever is lower. Next, Section 6.1 of the Alpha Generator Notebook defines the parameters of the jobs that will be submitted, which include start date. This is the start of the entire period for which predictions will be made. End date. This is the end of the entire period for which predictions will be made. Refit freak. This is the frequency at which the model is refitted, which can be M for monthly, Q for quarterly, or Y for yearly. Train lookback years. This is the number of years of historical data to consider for training the model. This value defines how far back in time the training data should go. Holding period. This is the duration, in days, used to calculate the forward returns. It defines the window over which future returns are predicted. The forward return is computed on a rolling basis, where the calculation is performed daily, using a window that shifts by 1 day for each new data point. X days look back. This is the number of days to look back when reading the datasets, ensuring that additional data is included at the start to prevent Neon values in backward-looking or rolling transform features. This is the amount of memory to be allocated to run a single refit period. Participants need to take this into account when choosing the instance type for the node balancer. Results out dir. This is the output directory for model, predictions, and notebooks generated during parallelization. Section 6.2 of the notebook constructs a new notebook for each period from the start date to the end date, containing the code for training the model and for generating its predictions for that period, which it saves to results out dir provided in Section 6.1. After constructing these notebooks, it submits a job for each period that runs all the cells in these notebooks, which then trains the model and generates predictions. After the jobs are done executing, you can inspect the models and predictions, as well as the notebooks that generated them in results out dir. If the jobs run successfully, it should have the models directory, which contains the models and feature importances for each refit period, the notebooks directory containing the notebook for each refit period, and the YPRED directory, which contains the daily stock return predictions in the form of CSV files. In the next video, we will discuss the contents of this directory to help participants gauge their model's performance.